It's that the cause again, and in this video we'll be looking at the chemical reactions of chlorine. In the previous video we looked at the test for chlorine gas and also the physical properties, but here we'll be looking at the chemical properties of chlorine. Number one, and the most important, is its action inside the water. Chlorine dissolves in water to produce two acids, oxochlorate 1 acid and hydrochloric acid. This oxochlorate 1 acid, HOCl, and hydrochloric acid. This oxochlorate 1 acid, HOCl, is known as chlorine water. So when chlorine dissolves in water, it forms what we call chlorine water. Now this chlorine water, when you expose it to sunlight, it decomposes to liberate oxygen gas, and that's what we are looking at in this diagram. Here contains chlorine water. Now when you expose it to sunlight will decompose the chlorine water and give out oxygen gas. So that is what happens, and this is what makes chlorine a very strong bleaching agent, because of the formation of that oxochlorate 1 acid, which will give out oxygen gas. So you're going to bleach any compound or bleach any fabric or any dye by oxidizing the dye. Look at the equation which you are supposed to learn, which you should learn. HOCl, two of them give you 2HCl plus oxygen gas. Number two is as a bleaching agent. Chlorine bleaches by oxidation, like I told you before, because it can form oxochlorate 1 acid which release oxygen easily, and that's the reaction equation on your screen. If you get HOCl by adding chlorine to water, it produces oxygen gas. Then that oxygen gas will go and react with the dye and bleach the dye, so the clothes will turn colorless, and that is what tells you that chlorine gas is a bleaching agent. Apart from chlorine, one other gas acts as a bleaching agent. The gas is sulphur 4 oxide. Now sulphur 4 oxide also bleaches just like chlorine, but there are differences in the bleaching action of the two gases. For example, chlorine bleaches by oxidation, whereby SO2, that's sulphur 4 oxide, bleaches by reduction. Number two, chlorine, its own bleaching action is permanent. When chlorine bleaches you, you are bleached forever. There is no hope of regaining the color as a fabric. But if SO2 bleaches you, because it bleaches by reduction, if you expose the fabric back to atmospheric air, the color will return, because the cloth will be oxidized back and the color will return. So SO2 bleaching is temporary, but the one of Cl or of chlorine is permanent, very permanent. So that's why some straw hat that has been bleached by SO2, when you keep wearing them for a long time, they start turning yellow, because as you're exposing them to atmosphere, the color will be returning, because they start getting oxidized. Normally you don't use chlorine to bleach straw hats and wool that are very delicate, because chlorine is a very strong oxidizing agent. So you end up using SO2 that is not very strong, is a mild oxidizing agent, and because it will not destroy the fabric, it will not destroy the straw hats, that's why you use SO2. So but because its own bleaching action is temporary, the thing will turn yellow after some time. Number three reactions of chlorine is its reaction with slaked lime. Slaked lime is calcium hydroxide, as you can see in the equation, Cl2 plus CaOH2. So when you react chlorine with calcium hydroxide, it will give you bleaching powder. That popular bleaching powder is calcium oxochlorate 1, calcium hydroxide or calcium hypochlorite. So that's what you see in this place. It gives you bleaching powder. When you add acid to bleaching powder, it liberates chlorine gas. Number 4 is the reaction with sodium hydroxide. Well, we have talked about calcium hydroxide. Now we are looking at the reaction with sodium hydroxide. Sodium hydroxide is caustic soda if it's concentrated, and there are two conditions that affect sodium hydroxide reaction with chlorine. Number 1 is the concentration of the sodium hydroxide, and number 2, the temperature of the sodium hydroxide. So if chlorine reacts with hot conc, or let me start with cold dilute. If it reacts with cold dilute NaOH, that is, the temperature is low and the concentration is very low too, chlorine will react with it to produce sodium chloride with sodium oxochlorate 1 and produce water in the process. So learn the equation and learn the balancing of the equation. So that's what will be formed. However, if you change the condition and increase the concentration of the NaOH and the temperature also, that is, you are now reacting chlorine gas with hot concentrated sodium hydroxide, it will still produce sodium chloride. However, the next compound will not be sodium oxochlorate 1. Instead, it will be sodium trioxochlorate 5 and liberate and also produce water in the process. So the major difference between the two reactions is in the production of sodium oxochlorate 1 for cold dilute and sodium trioxochlorate 5 for hot concentrated NaOH. So the rest product are the same. Learn the two equations and learn the balancing. I call this 63513, where in this place only 2 for sodium hydroxide is enough to balance the equation. Displacement reaction. Because chlorine is higher than bromine and iodine, more reactive rather, in that series, so chlorine can displace bromine from its salts and can also displace iodine from its salts. The only element that chlorine cannot displace is fluorine from its salt in that group, because fluorine is more reactive than chlorine. So if you react chlorine with potassium bromide, chlorine will displace bromine and give you KCl and then produce bromine in the process. So the color of the solution will now turn orange from colorless. However, if you do similar thing for potassium iodide, chlorine will displace iodine, and iodine will be displaced inside the water with brown coloration. So all these are showing you that chlorine is more reactive than bromine and iodine. Ionically, it can be written also in form of ion. When you see Br minus, it's telling you that it's a compound of bromine. So chlorine can react with it and displace the bromine to become a Cl minus, meaning that chlorine has displaced the bromine, and Br minus will turn to ordinary Br2. The same reaction that will occur is what we occur as we have shown there. There will be orange coloration if bromine is discharged, and there will be brown coloration if iodine is discharged. It's a displacement reaction that tells us that chlorine is more reactive than iodine and bromine. With hydrogen, chlorine can react with hydrogen to give us hydrogen chloride gas. Hydrogen burns very rapidly inside chlorine gas to give us HCl gas, and if you test that HCl gas that is formed with aqueous with a NH3, it gives us a white film, as you can see in the picture above. Can you see the white film? All right. With hydrogen sulphide, when chlorine reacts with hydrogen sulphide, it displaces the sulphur. So there will be a yellow deposit of sulphur. There will be yellow deposit of sulphur when chlorine reacts with hydrogen sulphide. With methane, when chlorine reacts with methane, it substitutes for one of the hydrogen there. That is, out of these 4 hydrogen, one of them will be replaced by chlorine, so it gives us CH3Cl. You call that a substitution reaction. Then any NH that has been replaced here will form a new compound with the remaining Cl. So that is called a substitution reaction, giving us trichloromethane with HCl gas. However, if you carry out this reaction in presence of sunlight, a chain reaction will occur where all the hydrogen in the methane will be replaced by chlorine. So all the H4 will turn to Cl4. It's a chain reaction. The reaction will continue until the end, until all the H has been completely replaced. Then gives you HCl finally. With ammonia, chlorine reacts with ammonia to produce nitrogen gas and ammonium chloride. This ammonium chloride here, and the nitrogen gas is collected away in that second tube. So that's the reaction of ammonia gas with chlorine gas. With turpentine, turpentine catches fire rapidly in chlorine jar to produce soot and hydrogen chloride. Soot is carbon, and this is hydrogen chloride. As you can see from that video, you see how it catches fire rapidly and produce soot and release hydrogen chloride in the process. So these are the reactions of chlorine that you should understand, and note the equations of the reaction and understand what happens in terms of color changes, whatever that is deposited. Then try to understand that very well. So this will be all that we're discussing about the reaction of chlorine. God bless you.